Hi children, welcome to EduCub. Today we are with a new video from grade 7 science. Now we are discussing unit 11 sound. Our first subtopic is production of sound. We hear various sounds frequently in our day-to-day life. Sounds of birds, sounds of radio and television are some of them. Let's do this activity to find out more about the sounds we hear. We need a speaker, some pieces of polystyrene, connecting wire and risers. What we have to do, connect the wires to the terminals of the speaker. Place the pieces of polystyrene on the speaker. Connect one of the two free ends of wire to the riser. Touch the other free end of the wire with other terminal of the riser and remove at once. Do not keep the wire connected to the risers. Keep one touching and removing one end of the wires to the riser and record your observation. It is observed that pieces of polystyrene are thrown up only when the speaker is connected to the risers. It means that pieces of polystyrene are thrown up only when the speaker produces sound. This happens because of the to and fro movement of the speaker cone. This type of a speedy to and fro movement is known as vibration. It is clear that sound is generated due to the vibration of object. Let's find out more about the generation of sound. We need tuning fork, a laboratory stand, a pieces of thread, a small polystyrene ball. What we have to do, hang the small polystyrene ball using a piece of thread like this. Vibrate a tuning fork and bring it close to the polystyrene ball. Observe what happens. Repeat it several times. It is observed that the polystyrene ball moves toward the vibrated tuning fork when it is brought closer. The polystyrene ball moves only when there are vibrations in tuning fork. Let's find out how our vocal sound is produced. What we have to do, place your fingers on the middle of your throat as shown in this figure. Speak slowly and record your finger feels. Speak louder and record the feeling of your finger. A light trembling is felt to the fingers when speaking slowly. This trembling increases when the voice is increased. This type of trembling is felt because of the vibration of membrane in throat, which are known as vocal cords. That means our vocal sound is produced because of the vibration of vocal cords in the throat. Let's see the instruments that produce sound. We need guitar, drum, flute, and a tabla. What we have to do, produce sound using the sources of sound that you are provided to it. Observe the part of the sound produced that vibrates when sound is produced. Tabulate your finding. Let's say I have tabulated the sound source, that means instrument, and part that vibrates. Guitar, strings. Drum, membrane. Flute, air. Tabla, membrane. Accordingly, it can be concluded that various musical instruments produce sound in various ways. Musical instruments can be categorized according to the part that vibrates to produce sound. These are that classification. Sound sources, vibration of strings, vibration of membranes, vibration of air. You can see some examples. Our next subtopic is propagation of sound. In classroom, you hear the voice of your teacher. In space, two astronauts cannot hear each other voice despite being closer to each other. What the reason for this? Let's find out about that. We need a bell jar, vacuum pump, an electric bell, few dry cells, connecting via a switch. What we have to do, fix the electric bell in the bell jar as shown in the figure. Connect two dry cells and to switch to the supply electricity. Connect a vacuum pump to the bell jar so the jar can be evacuated. First switch on the electric bell and record your observation. Then switch on the electric bell again and while evacuated the air in the bell jar using a vacuum pump, record your observation. Finally, switch on the electric bell again and the bell jar is completely evacuated. Record your observation. Ringing of the electric bell can be heard when the bell jar is filled with air. When the air in the bell jar is gradually evacuating, the ringing of the bell gradually faded. The air in the bell jar is completely evacuated, ringing completely fades off. It is clear that ringing of the bell is heard only when there is air in the bell jar. Sound is not heard in the space where there is no air, in vacuum. Thus, it is clear that the medium is essential for sound to propagate. We hear voice of the teacher in the classroom because sound travels through the air towards our ears. But two astronauts in the space cannot hear each other because there is no air in this space for sound to travel through. This is clear that sound does not travel in empty space and sound needs a medium to travel. Sound which is produced from a sound source travels where it is originated, known as propagation of sound. We hear different sounds when sound propagates through air to our ears. Does sound travel only through air? Let's find out whether sound propagates through air, liquid and solid medium. We need three plastic funnels, pieces of rubber tubes, membranes of balloons, a basin, wire tube and water. What we have to do, assemble the equipment as shown in the figure. Hold the funnels A and B on your ears and dip the funnel C in the basin of water. Make a sound near the funnel in the water. Record your observation. Sound made in water can be heard well through funnels A and B. Thus, it is clear that sound travels through liquid like water. When shallow grounds are flooded, the sound of the vehicle traveling nearby roads can be heard louder than the other days. The reason for that is sound travels through the liquid faster than through air. Let's find out whether sound propagates through solid medium. We will need two empty yogurt cups, a long thin thread about 10 meters. What we have to do, connect the bottom of the two yogurt cups to the thread as shown in the figure. Get some support of your friend to this activity and keep one of the yogurt cups to your ear. Tell your friend to go as far as possible, keeping the thread of well stretched, and speak into the other cup. You can hear your friend clearly. Thus, it is clear that sound propagates through the thread. Let's test whether sound travels through solid medium. We need clock giving tick sound and a long table. What we have to do, keep the clock at one end of the table as shown in the figure. Stand at the other end of the table and test whether you can hear the tick sound of the clock through air. Then place your ear on the table and listen to the tick sound of the clock. The tick sound of the clock can be heard through the table more clearly than through the air. It is clear by above activities that sound propagates faster through solid medium than gaseous medium. The sound of the train coming from far away can be heard clearly when the ear is kept on the rail line. This is very risky activity. The reason for this is that sound travels faster through solid than through air. We can hear the sound emitted by dolphins more instantly when we are in underwater, but the same sound emitted by them above water is heard very lightly. The reason for this is that sound travels faster through water than through air. The speed of propagation of sound through solid, liquid, and gaseous media is different from each other. Sound propagates faster through solid than through liquid and gases. The speed of sound is least in gaseous medium. Let's see medium and speed of the sound meter per second. Air 330, water 1500, steel 4500. During lightning, thunder is sound and the light emitted at the same time. But we hear the sound after few seconds of seeing in light. The reason for this is that the speed of sound is slower than that of light. Thank you. This is what we have to discuss throughout the sound lesson. Our next video is biological processes. Thank you.